Crude oil is a mixture of these compounds, these hydrocarbons called alkanes. Okay, and alkanes differ from each other in the number of carbon atoms they have. So you have the simplest alkane, which is methane, which is CH4, and that's a gas at room temperature. It's got a very low boiling point. And as the carbon atoms get longer, so let's go up to pentane, which has got 5 carbons. That boiling point of that is 36 degrees C, so that would be a liquid at room temperature. Pretty volatile liquid. Okay, now crude oil is a mixture of alkanes, and they range in length from about 1 to about 50 carbons long. Okay, and crude oil itself is no use. You can't use it as a fuel. It needs to be separated into these things called fractions. Now, fractions, so you have to define one. It's a collection of molecules with similar carbon chain length. So let's look at one of the fractions. Petrol here, used in car engines, that contains alkanes between 5 and 11 carbon atoms long. And kerosene, which is used in, sometimes called paraffin, it's used in jet engines here. That's a bit longer, between 12 and 16. Diesel, which is used in cars and lorries, longer still. And finally, very long molecules, which make up bitumen, which is a black tarry stuff they put on roads and use for waterproofing roofs and things. Okay. Obviously, as these molecules get longer, what's going to happen is the boiling points are going to increase. And that is how we separate them. We separate them by fractional distillation, okay, which exploits the fact that they have got different fractions, different molecules have got different boiling points. So this is how it's carried out. I should say, just before we start, let's have a look at this here. Right, a liquid, when it turns into a gas at a particular temperature, it boils. So water boils at 100 degrees C. And when the gas turns back into a liquid, that is called condensing. And the condensation point of steam is 100 degrees C. So the boiling point and the condensation point of a liquid or gas are the same temperature. Okay, now fractional distillation separates on the basis of the fact that they've got different boiling points or different condensing points. So this is called a fractionating tower, and these are found in oil refineries, and they are 70, 100 feet tall, and the bottom of the tower is kept at very high temperature, whereas at the top the temperature is cooler. Okay, so what happens at the bottom is boiling crude oil enters the bottom of the fractionating column. Now, if you've got a little molecule there, I'll draw this molecule. Imagine it's quite a long molecule. That will condense here, even though the temperature is very high, and so that is going to turn into a liquid, and it's going to come out there. And what that will be actually bitumen, which comes out there because it's very long molecules, very high condensation point or boiling point. Let's think about a very short molecule, a little tiny one like that. Now that will not turn into a liquid, so it's going to rise up the tower, and it's going to make its way up the tower, and it's going to stay a gas, and it will even stay a gas when it gets right to the top there. Let's get rid of that arrow. Okay, and that fraction is called refinery gas, and that's going to be molecules with less than 5 carbons long. So that can be used for various things. Okay. Now, let's think about the other fractions then. So if you get fairly short molecules, So it's not as short as refinery gas, just a little bit longer. That will remain the gas until it gets up to the top layer, and then it will condense, and then it will be tapped up as a liquid there, and that is petrol, which is used in car engines. Molecules which are a little bit longer, they will condense at a slightly higher temperature there, and that will be kerosene, the fraction kerosene. And then you'll have diesel, and then here there's a fraction which is usually called heavy fuel oil, which is used in ships and things. And finally you get the really heavy fraction, bitumen, with very long carbon chains. That's the black tarry material. So the main thing to realize there is that crude oil is separated by fractional distillation, and that is achieved because they have got different boiling points. If you've done a later video, don't confuse this process with cracking. Cracking is different. There's no chemical reactions going on here. You're just separating substances from each other on a basis of their different physical properties.